Welcome to Matrickz Tech Talk.
In this episode, Hans Leo Ross talks about how safety will be the enabler for autonomous vehicle.
Today, I'm super excited to have the legend of functional safety in the room, Hans Leo Ross. Leo, welcome to Matrickz.
Thank you, Hassan, and for that warm welcome here.
Leo has been working in the field of functional safety over 25 years. He is the author of two very important books in functional safety. One of them I have on my table, Functional Safety for Road Vehicles, and the other one is in German. I recommend you to have a look. He was heading a working group for the German VDA, which eventually developed the ISO 26262 standard. He started his career in the oil and gas industry. So Leo, I will pass it over to you now to tell a little bit about yourself, your passion, your background. How did you get into the topic of functional safety?
Yeah, at the end it is always like when you deal with safety, it happened with accidents. And we had a big project and we have to build up at the end an automation system for automated train truck loading system with liquefied gas. And at that time they told me, because I was the youngest, to make the project. And then we recognized, oh wow, a lot of safety requirements. Nearly all the requirements derived due to safety arguments. And we had a hell of really impact a lot of people, stakeholder who had at the end many particular safety requirements in that one. Yeah, and I went to the first meeting, had a lot of very important people which asked me how I would solve and how I would make that. And I came back to the company, I told all to my colleagues, I have to do that, I have to do that. And that is their expectation, what I should do. And all my colleagues looked at me, we never did it. How can we do it? And unfortunately, 25 years later, I still don't come out of that.
Fascinating. So how did you enter from oil and gas to how did you start your journey in the automotive functional safety?
At that time, I was working for an engineering company who did at the end really develop total tank farms, refineries, pipelines, etc. for oil and gas industry. So I did at the end plants all over Germany, even in Norway, in Libya and things in all that countries. I did quite a lot of projects, so I had international experience, as I had also a lot of experience in other countries like Italy. So I built the first automated loading system and control system for liquid gas on gas carrier and all that stuff. And so, I made a lot of international experience and a lot of experience with safety. And then Boysak decided to sell the business, so they stopped doing at the end oil and gas. They stopped at the end doing, and the company completely changed, and was looking around what to do now. Yeah, of course, you have safety experience, I have international experience. And so in the first years, I started 3 years of doing sales for a very small safety PLC company. And at the end, I sold safety PLCs to the world. And so I made quite a lot of experience with the oil fields in Norway. And I did quite a lot of detailed experience how to control oil platforms, how to control pipelines. So Europipe 2, we made the first system which had been controlled by satellite. So that is very famous. So we get here now, we get in winter time, we get all our liquefied gas from Norway via that pipeline where I made the safety system via satellites. And these were some very challenging products. And then I came back always to my colleagues in the development and told them, we have to care a lot of new safety standards and we have to develop the product according to new standards like IEC 61508 and all that stuff. And I said, yes, but you must help us to develop adequate products for those things. And so I became the head of product management and I starting at the end new PLC system, new structure, new architecture, how you could at the end control safety related processes and safety related actions, events and whatever all behind that one. And one of the key issues, since we were a very small company, we could not develop our own safety bus like Profibus and all that stuff. So we had to use existing technology and making safe. So we introduced safe Ethernet to the industry. We start at the end really building complete new ways how to control processes, batch processes, etc. Yeah, and one day at the end I got a call. We need that also for automotive industry. Can you help us doing that also for automotive? Yeah, and so I came at the end into the automotive industry. At that time, of course, safety was important, but it has a different meaning. Yeah? So it was not that what we understand functional safety. It was really just safety by design. So at the end, you designed the front of a vehicle. There were the discussion about safety belt, airbags in the car, so occupancy safety were big on the car. But the electronic was just designed as it was needed in the car. And so I think at that time I had first to analyze what is in the car, how to deal with the electronics in the car, what is the job of electronics in the car, what is doing. At that time we start discussing about drive-by-wire, steer-by-wire and stuff like that. Brake-by-wire were very interesting application where we were thinking about, but also even the basic car, just basic functions like braking, steering was still some room for improvement in terms of safety. And so we start a lot of pilot projects, and in parallel I joined at the end the VDA working group, and we started to develop a really adequate standard for the needs of automotive industry. Yeah, and after some while I was at the end here deeply involved. Unfortunately, I was also at that age already the most experienced one with real safety. So I did at the end, for example, all that analysis for my product. I did at the end really a lot of application, of course, in the oil and gas industry more, or in machinery industry. But so I think I had quite a lot of experience with all the different kind of impacts and how we did it. Yeah, and so I was involved in the development of the standards. Later on I became the head in the German VDA group, and I had to find all the compromises which we today working and fighting in ISO 262, how to apply that. Yeah, and now it seems to be that we even now on the next big progress that we're ending up really with e-mobility, that we end up with automated driving function, which is another set, especially for safety, how to improve the new technology with electronics and safety.
Fascinating. So you gave us a fantastic picture how things developed the entire last 20 years probably, and now you ended up with a very, very important topic, autonomous vehicle. So Google just ordered 62,000 Chrysler and 20,000 Jaguar for their autonomous vehicle fleet. These numbers doesn't sound like for lab testing. My guess would be they're going all in the autonomous driving business, and the party is getting started sooner than we anticipated. So my question is, do you think the industry is getting into autonomous driving a little bit premature in terms of functional safety?
I was head of the German working group for functional safety, and I think we in Germany were strongly dominating at the end the safety process and the development of the standard. And my feeling is that we in Germany have a quite deep knowledge what in terms of safety is really necessary to do and what's all behind on that one. And companies like Google, Waymo and all the others, Uber, need to make their experience on all that stuff. And just to do the experience on one car is one experience, but doing really on a mass production car and with all the tolerances on production, etc., making the experience really in different kind of environment, different kind of operation modes, different kind of weather conditions and all that stuff are huge exercises where, of course, here the traditional car manufacturer have really a long history. They know what is the impact on steering, they know what is the impact at the end on braking, on driving strategy and all that stuff behind that knowledge, and companies like Waymo have to make all that experience. So I think in the car itself, I think the traditional car manufacturers have that history and have that experience, and also the tier 1 supplier like Bosch, like Conti, like ZF, know quite well at the end what is the challenge on the product that you want to develop a serious development car. So I think once making a remote driving car or an automated driving car is one thing, but building up a fleet and building up at the end in mass production condition and at the end later on doing mass production for this kind of technology is a complete other question. And yes, they have to make that experience and therefore they need that mass production fleet at the end of the road to make their experience, but I didn't consider that they make already commercial benefit with all that exercises.
So Leo, you mentioned 3 big disruptive paradigm shifts that's happening in the automotive industry right now. Autonomous vehicle, electrification of a vehicle, and connected cars. So what do you think, what kind of challenges do they bring in the industry, and how should the industry deal with such challenges?
I think, first of all, electrification, we have high voltage now in the vehicle. We never had high voltage in the vehicle, and so we need to learn to deal with it. And so even in the garage and wherever we repair, maintenance doing for that one, there are some challenges. So, you know, for example, charging station at the end is still a big discussion. We don't have the infrastructure for that one. So there is one point. Even if we go now to alternative fuel, for example, hydrogen, how do we deal with hydrogen? How we maintain at the end hydrogen systems within the car is a big job. Is at the end really the battery, so that we driving with 500 kilos of battery with the cars, or do we drive with 100 kilogram of hydrogen, or maybe even including the iron tank that you need at the end for transporting the hydrogen that for that? Is the question how we deal with that and what will be the technology of the future, or do we see still some hybrid which will in certain situations still with a traditional combustion engine and stuff like that, is one question for the electrification and the new mobility which coming up, and what is really the powertrain of the future, how will it affect, or is it any combination? So do we maybe come from the piston engine back to a disc engine, how we had it 40 years ago already in some vehicles on our roads? Well, we don't know, but we see how the market, how the demand. I think when we're talking about connected makes, of course, not that much sense if we just get the information and can switch on the heating in the vehicle in the morning. There is no real benefit for some people, but nobody could make a real business case out of that. When you need really automated driving function, then you need at the end transportation. You must at the end find some benefit, of course, also for safety, due to that reason why we make connected. But in connected, of course, we have at the end the issue that everybody could be connected, so also the people that we want to lock out of that experience. So of course there is a real threat to some security actions and things like that, which could lead also to very new challenge how to deal with that. And that is the question, what is the motivation for that people? Do they just want to attack other people with the car, or do they want to steal the car? So here we're coming to a strong overlap of security and safety, and we have to think what are the new mechanisms, how they could cooperate and how they could coexist at the end in all our control devices, and how we can manage that is a big question. And automated, yes, of course, I want to have a benefit. So for example, today we're driving here to that location still, and we need a driver, and we have to drive by ourselves. Maybe one day the system does it for us. And that would be a benefit, because during that time we could relax and could talk about, prepare ourselves for the discussion, etc. Now we have to concentrate on the traffic. So then you can make a business case, then you can provide solution. But of course the technology at the moment is not there. Even in avionics at the moment, they don't fly completely autonomously to the air. Railway, we have, for example, in Nuremberg, underground system at the end which works unmanned, and so it is system operated, but these are spots. And so an overall remote technology or automated mobility industry doesn't exist, and at the moment nobody has really an idea how it could work. And so we have a lot of challenges. What kind of technology, what kind of information technology, what are the criterion that we need at the end to do those things is still a question mark.
So you mentioned very interesting topics. like hydrogen or high voltage. We have now either hydrogen or high voltage batteries. So what are the safety consequences of such technologies?
I think the big challenge is at the end the different kind of impact to safety. For example, hydrogen is very complicated to treat and to manage hydrogen because it's highly explosive, and that is really also from a point of gas. So that piece of wood cannot block from hydrogen to going through. Even the normal iron cannot stop hydrogen to go through iron and stuff like that. So at the end, to protect that, and the reactivity of hydrogen is extremely, that's a good thing. If hydrogen reject with oxygen, we simply get water. And that is at the end a big benefit. So we get a pollution of water, which is really for our future an important thing.
However, you're saying that safety impacts will be, we're not ready for it. The technology is not safety-wise matured enough.
Whenever you're doing driving, it is a kind of kinetic energy. The car is driving, so it's moving. You must control the kinetic energy. The same is at the end when you use new fuel. You must be able to control that. Otherwise, you cannot provide safety to the people who are handling that and also the people in an environment. They want to have a safe technology. And that is the key point for all that new developments.
So the same question goes for security. So in today's environment, when we talk about e-mobility, autonomous vehicle or connected car, in these three disruptive scenarios, how do you think the security measures are taken right now? Because that will also have safety consequences.
Yeah. I think in terms of security, you have a lot of threats, and most of the threats at the end have a certain degree on priority. At the moment, for example, theft protection, we know from the press, we accept a certain degree that people steal our data and that people steal at the end our cars, etc. And so there is a certain level of acceptance that it is tolerable for the society. But unless it comes to threats to life of people and it comes to safety issue, we don't tolerate it. And so we have at the end in safety classically already foreseeable misuse where we have to deal with. But when we have active misuse, that people really want to build up a vehicle as a gun because they remotely control the vehicle into a mass. So I think 2 years ago we had the issue on the Christmas market in Berlin where we had a manual driver, but later on people tried to do that remotely at the end. And when we consider all that events, we don't want that. And even the society don't want to take that kind of risk. And so I think it is a strongly demanded thing. So since we want to have automated driving things, we want to have remote driving vehicles, we must also prevent that become at the end a threat for the society.
How about the standards? Are these issues being reflected in the standards? How mature are the standards to deal with such new disruptive paradigm?
I think that in the nature of a standard is at the end a repetition or an explanation of state of the art. When you make new things, you need also new standards. So unfortunately, we cannot give in a standard an answer for the future. And also all the history of safety came up with problems. So the society doesn't accept certain threats, certain risks. And so the governments introduce at the end regulations, for example, road release, homologation, etc. All that stuff make a strong impact. And they all developed from very easy rules and regulation. So all our road traffic regulation had been developed due to the fact that we get more and more cars, that we get the cars closer to people, etc. And all that stuff had been developed over many, many years. So the German Straßenverkehrsgesetz is nearly now 110 years old. And so I think over this 110 years, it really strongly changed and gave new insight. So in 1908, we have just a few cars, and it was very seldom, and was just to find registration and some rules that they should run on roads which are not really designed as we consider today roads, etc. And all that developed, and I think since we don't know in what direction our future mobility goes, we still don't know also not how safety technology will increase. But before we bring the technology really to mass production and that we bring it at the end in the public environment, in the public road condition, in the traffic, we must be able to control it. Otherwise, we risk the life of a lot of people.
Can you also explain a little bit what is SOTIF and why do we need SOTIF on top? We have ISO 26262. What are the differences?
When we develop ISO 262, we exempted quite a lot of risk which lead at the end to harm for people or which lead at the end to risk which people don't tolerate. And at that time when we developed ISO 262, it was at the end target the existing technology and find at the end solution how to make the electronic mature enough and safe enough at the end to control the existing. But later on we realized we want to do much more with electronic in the car. And then, of course, we saw, yes, intended function. We want to have that a system drive a car. We want to have at the end that the system monitor the environment. When you make your driving license, you learn to monitor your environment. You have to see there are children on the side, there are at the end things. That is all responsibility for the driver. And now we want the system doing that for us. And so the system must learn that, also to do that in a safe way. And that is the reason why we need to control our environment, that we need to see, is the function itself mature enough, safe enough, correct enough to make a safe trip from Munich to Hamburg or wherever. That we need also, for example, SOTIF, safety of intended functionality, how we control at the end the intended functionality, so that these active functions could be made safe, which today in our technology is task of the driver.
We have new standards, as you mentioned, SOTIF is required now. How should the safety and security architecture in a vehicle look like in the future to accommodate such disruption or innovation?
Yeah, I think if you have a computer, it should be safe, because when it explodes and you get at the end injuries due to the explosion of the computer, you have a safety impact. But of course you need a firewall in your computer. It is not really separate. And the same is when you're within a car. And of course we have to learn how to develop requirements of all that different kind of threats or risks that we need to control, and how to bring it in communication, in networks, in control systems, and whatever we use at the end to control later on our future ideas about mobility. And here we have to see at the end how a coexistence is working. I think one of the key issues which we experience during the last development and the last exercises when we're working more and more with automated driving idea, one of the keys for the future technology is the availability of a safety-related function. And when we have that availability of a safety-related function, of course a security impact could also lead to an unavailability. But how do we deal? We cannot shut off simply the car in one, because then you cannot steer anymore the car. So if you go close to a corner in the road and you make a security threat and you switch off the car, you go straight on and you kill the driver, the occupants from the car, or maybe people in the environment. So just to make it unavailable could lead at the end to accidents and incidents which you don't accept. And so I think we must learn how to make proper architecture that all that risk detecting or threat detecting mechanism at the end could coexist then with each other, and that we find at the end solution how we react on that one. We must learn to separate. For example, if you have a communication system and you have a security impact, you cannot switch off the entire communication system. So if your mobile phone device, if for example in Germany we have the DNet, if you switch off the DNet just where have a security impact, you cannot switch off the complete mobile phone telephone network. And so we must make modular approaches, structure how we detect, how we control, how we evacuate, how we contain faults, but not only due to safety, but also to security and other kinds of impacts that our system could have, so that we can provide at the end an infrastructure, a functionality which is necessary to control our mobility.
So how about a trade-off between safety and security? So we've seen scenarios where I want to ensure my system would trigger a certain function within 50 milliseconds. However, I also want to ensure that this function is not accessible from someone who is not supposed to. So I have to introduce crypto, and crypto costs time. So there, we've seen a trade-off question. What's your take on that?
I think that will be a quite big challenge. If you go, for example, to an Z80 and you want to implement a 64-bit hash sequence, it would be impossible because the microcontroller just have 8-bit. And so you are quite close to the limit of that one. And also for the safety, for the algorithm, for the timing, we need at the end very fast, high performance computers to do that, which have the ability. And without that high performance computer and with really having those highly technical, elaborated system which can deal with that big number of keying in the system, which can react fast enough in the needed time, etc., we will have no chance to control at the end that what we do.
So we've seen that we had to choose a lesser evil, yeah? And with that, the questions of legislation come into play. A disclaimer that none of us are lawyers. This shouldn't be taken as a legal advice. We are having a technical discussion. However, it is also a technical question that who is liable? Mm-hmm. What the ethical issue and the liability issue? Because do we sue the driver? The driver is not driving. Do we sue the OEM? Do we sue the tier 1? Do we sue the tier 2? How do you think these things will be tackled in the future?
Unfortunately, the product liability regulations and law are much older than even the road traffic regulations, and they have a basic principle. If you want to have a technology and if you bring at the end the technology in public use, you are responsible for that one and all the damages that occur. The question is, for example, all the responsibility that the driver has today. He does not drive anymore in an automated driving car. So this responsibility somebody must take who developed the system, who drive the car. And I think that is a question where we have to discuss with our insurance, where we have to discuss with the government, etc. But even already the basics that we have for our road traffic regulations, the Vienna Convention had been changed, that now really systems are allowed to drive cars or to control certain functions on cars, etc. So it is not anymore really the key demand that the driver control the cars in any situation. And nearly also the local legislation, so the German Straßenverkehrsgesetz had been changed, and they have to introduce really a paragraph to that one, which at the end deals when you make technology which control the car, then you are liable as the provider of the technology and not anymore the driver. But that leads to new regulations, to new judicial practices, and of course also insurance have to be found how to deal with that. There are already in Germany some insurance company which say we are motivated to support automated driving functions. So you would find at the end also industry that support that in this terms of this kind of new risk that you bring to the society. And of course, there will be new business and there will be new stakeholder of all of that. And we have to find a solution for that one, because also an insurance company will not pay simply for all the damages. They will ask us to make measures to prevent that damages. And then we are back to security and safety.
Absolutely. So you mentioned a very, very, very interesting point. So when we move to autonomous mode, fully autonomous mode, so today we have 3,500 deaths in the German roads due to car accident. The hope is maybe we can reduce the number. However, still we know that there are certain scenarios, very less probable, but we won't be able to handle with today's technology. So do you think it's choosing the lesser evil? So, I mean, is autonomous driving more ethical than that person driving?
I have to admit, it had been never introduced any technology in the world where we didn't have at the end an increase of dead people and injuries due to the new technology. There are two effects coming together. Mm-hmm. The traffic and the demand on traffic and the demand on mobility is increasing. So the planes in the air, the cars on the road, you see it's increasing since years, and we have really a big demand on mobility in the society, and even the government wants to support that big demand. And of course, as more people you have in a very narrow area, as more risk you take. And so I think it's in the nature of things that we also increase the risk to all of that. But the question is really that we find quite soon solutions, how we can manage the risk, how we can reduce eventually with the new technology the risk. And I think that is a race. Are we fast enough to improve the safety with the new technology, to coming also all the demand on new mobility, on increased mobility, and finding good solution on that one? Or do we wait unless we have accidents too much, which we don't want to accept? I would prefer to increase and develop more safety solutions at the end to prevent that we get that heap too strong.
In the meantime, Leo, let's take a question from our audience. So just to tell you a little bit, you can ask questions to our guests directly. It's a rare chance to have a one-to-one with people like Leo. So please, I encourage you to write us at podcast@matrickz.de or direct message me in LinkedIn or Zing or Facebook, wherever you want to. We'll be happy to have you as a part of the show. The first question we'll take today is from Santosh Mudal. Santosh, welcome to Matrickz virtually.
Thank you. Myself, Santosh, I'm basically working as a embedded engineer, and I'm basically working on engine management ECUs, basically in system engineering and software engineering. And here I take care mostly with respect to all the functional development of engine management ECUs. From past 8 to 9 years, I'm working with Robert Bosch, India, and I'm basically handling two different different kinds of projects where I also deal with functional safety topics or a kind of analysis at the first level. So it would be really interesting to speak to Mr. Rose. He's pioneer with functional safety. I am also one of the enthusiasts which I regularly follow, which are the latest updates with all the happenings in the technology with automotive world. My question is, now I'm working basically with the engine management ECU, but in future, when I look at the automotive trend, looking at the autonomous driving or autonomous vehicles, according to you, what could you think the major challenges in order to meet the safety? Because for me, it scares me sometimes looking at the trend of autonomous driving, where we are using machine learning, artificial intelligence, where even the functions are not behaving same way over the period of time due to the learning functions or the algorithms. So is there any chance, or can we think something that in advance, how can we achieve a safety under such circumstances or such changing environment of autonomous technology?
Very good question, Leo.
Yeah, one point from a pure technical point of view is still we have a lack of performance in our system, so we need the computing performance, and we have to work at the end that we get more efficient algorithm which detect really that what we need and which can control in that precision how we need the information within the vehicle. And the secondary is very close to that, which I already mentioned in our discussion, is at the end the availability of electronic functions. So we need continuous control. We could not tolerate interruption on the control of vehicle and stuff like that. And so I think especially the availability and the needed computing performance are very demanding things for the future.
Yeah, it is still growing, and it still has to come to the state that we have the stable available electronics and also the matured functions in order to also think about more safety. It's what I take it from this answer, or?
Absolutely. Yeah. So you had more questions?
If you have time, yes. I have one more question, Mr. Ross, to you. The second topic which also I deal with is with respect to the functional safety. If I look at the documents or with safety standard document, it all talks about the V model, putting this safety cycle into the V model of the product cycle. So now the challenge is with the new projects which we are working on, this all autonomous technology, we are going with little of towards agile world. So where it is getting difficult, or I see the challenges to put this or map this into the agile. Can you throw some points from your side based on the experience? Is it feasible, or what do you think, or what is your point on this?
If I understood your question right, you're pointing out that how agile methodology will fit into the traditional automotive processes. Is that what you're going to?
No, how safety can be fit into agile. Yeah, it's one
Safety
way that
processes and agile. How to combine those two?
yeah.
I think the question is really what you understand under agile. And I have to admit the automotive industry was always very agile in the development of new functions and introduce it. And sometimes we were lucky and we could bring that into the industry and we solved quite a lot of interesting issue by just trial and error. But agile does not mean really trial and error. And so I think there's also a very systematic approach, and we need this kind of systematic approach. If that's what we understand on agile is one question, or if we need maturity models, how we do iterative processes where we continuously learn what's needed, what additional needed at the end to come to our target is one point. But one point is really agile should not mean at the end that everybody could do how he wants and how he intends to do it. It must be somehow synchronized and that we get common targets for our activities. And these common targets we have to formulate, and these targets does not mean that we bring more risk to people.
Yeah, Mr. Yeah, it makes sense. Yeah, you're right. Maybe the generic agile methodology could be generic, but as you said, for automotive, it has to be more structured and could fit similar to V model in order to achieve the overall goal you meant.
Yeah, I think the V model is a standardized approach at the end how to cooperate between distributed development with many parties, and that you have at the end a continuous process how you develop requirements before we realizing, implementing things, and that you integrate it step by step unless to get the intended functionality, and of course in a safe manner. If that is the understanding of a V model, we still need a similar approach when we with many people working on such solution, etc. That is, I think, for me out of question. But how we tailor a V model, how we tailor the process, how we bring the things together, how we work later on the latest functionality, how we integrate artificial intelligence or neural networks into our technology, I think we will have an improvement and we will have benefits also from artificial intelligence at the end for our new functionality. But we must develop the rules, and the rules for that one are dominated by safety and security.
I totally agree with Leo. The V model is a project development life cycle. It is not contradictory, definitely not contradictory to Agile. You can tailor your V model with Agile-like flair.
I agree with this point as well, yes.
So you wanted to ask a third question?
Yeah, I have one more last question. Maybe here, this topic I often discuss, or at least with the conventional projects, I feel this safety life cycle or the safety topics are more kind of document work or a kind of extra work. In some places, I hear such things with the products which are there in the market from so long. And we always hear saying this is a kind of extra work until unless the customer really demands or the OEM really demands or he's told by the authorities to do it. Sometimes it might say that the safety life cycle is a kind of extra or redundant kind of a work which they feel. So I would like to hear some words from you, Ostos, being working for functional safety so long. Especially this is a problem because of cost and time, which is involved, which sometimes is significantly high for the products, and the small companies and startups could really feel this heat. So can you throw some thoughts on this topic, like how it is really important, or we really don't see the benefit during the product development or immediately once we put on the field, but overall, yeah, everybody understands safety is important, but in your experience, how important it is rather than considering it as an extra work?
Santosh, if I understood your question right, are you asking the ROI of safety, the return on investment, the business case? Or what do you mean by benefit?
Yeah, the kind of, because if I look at some of the products which are there in the market for so long, maybe are in the field for so long, people try to avoid it applying function safety. Now, if we are applying some little change with the existing systems, so they say if it is running fine for so long, then why should I spend so much again for function safety to maybe which is higher cost and time? So you are right. Maybe similar thing like return of investment when I really invest it on this functional safety for my new products.
This is a very interesting question, Leo.
Yeah, but the return on invest is one question. A new product has always two sides. I think when we see the challenge of Tesla at the moment to bring e-mobility closer to us, we see at the end in the mass production, they still have their challenges and they realize mass production is other regulations. And so they have to learn and have to accept that. So the question is, if we had forecasted with all the experience from the traditional car manufacturer that they could consider the skills of mass production earlier, they wouldn't have that problem and they would really earn a hell of money maybe with their approach. And that is the same for nearly all the startup and when it's coming up to safety. When, of course, experienced people who understand safety making new things, they immediately introduce the safety in the first idea into the last things. But if you have an idea and just make in the last few months just a safety envelope around on that one, you reduce the performance, you lose the benefit of the product, and it will cost at the end a hell of money to find the right safety mechanism to protect the idea. But if you have really the motivated, even in a small group, safety is not a matter of millions of people, so the safety society are not that many people who are doing that. But if you have clever safety ideas and you bring that at the end to the right product and you will find also your payback, because people buy the product not when they take a too strong risk, which we wouldn't accept from it, and then you get also the payback and the return on the invest on the product.
Absolutely. So I can tell you, Santosh, from my security perspective, when I go to a customer and try to sell security solution, there is no ROI in security, so they are reluctant. But when I just flip the number and say it's risk management, and you can put a number on the table, everybody's interested.
Okay, yeah. Yeah, thank you. Yeah, it's more or less, yes, I wanted to hear this. It's really clear now.
Awesome. Thank you so much. Really appreciate it, Santosh. It must be very late back in India.
Yeah, but thank you so much. It is worth waiting to speak to you and Mr. Rose, Mr. Hassan. So thank you so much for the call. And yeah.
You're welcome. Was a pleasure for me.
Was a pleasure. Thank you, Santosh. Have a nice evening.
Yeah, thank you. Have a nice evening.
Today we'll take another question from our audience. Bogdan, welcome to Matrickz virtually.
Oh, thanks.
Here's Leo. As you know, he's our guest today, so you have a chance to ask Leo a question. So what's your question?
Hello, Mr. Ross.
Hello, Bogdan.
I'm working for about 10 years in automotive field, so I've been working so far for various suppliers as well as partially for a couple of OEMs. For about, let's say, 4 years I've been involved in functional safety management. I started with part 6, so with safety software. My professional background is as embedded software developer, and to get more knowledge about the rest of the functional safety, so hazard analysis, the functional safety concept, various sorts of safety analysis. And since recently I changed the industry from automotive into machinery industry, since I wanted to get a grasp of other safety norms, say so. And for the time being, I'm trying to learn and to dive deeper into IC 61508 and ISO 13849. So that could be, roughly some words about my person. Since a couple of months, I started also as a sort of blog and to get involved in discussions with the safety community.
Sounds really great. Thanks for the introduction, Bogdan. So we're eager to hear your question. So what is your question?
One question would be the way the hardware failures are currently tackled in the ISO 26262 and how will a highly autonomous driving deal with that? So far the ISO 26262 is excluding any multiple failures having an order greater than 2. Yeah, so anything beyond dual point failures is basically considered in the hardware failure analysis as being neglected. In my view, this would be mainly because currently the ISO is meant for all the fail-safe systems and also for redundant systems, in which the main functional channel is supposed to be supervised by either by monitoring channel or to some extent could be also slightly fault-tolerant systems in which a second channel could take over the function execution. But once with the highly autonomous driving, we need, or the system needs to ensure very high fault tolerance. That would mean probably systems beyond simple or double redundancy. So triple modular redundancy or things like that with voting systems.
Okay, so if I understood your question right, there are several parts in the question. So for how hardware failure rates will be dealt in autonomous vehicle, and the questions about the redundancies. So Leo.
I have to admit, unless our system not mature enough to deal with random hardware failure, we cannot use it for automated driving. I think that is the simple answer to that one. We must get at the end really a solution how we can make a really proper hardware abstraction in the system and can avoid that hardware impacts really lead to any impact to the functions. And also to the degree of fault propagation, what you mentioned. At the moment, yeah, we consider for normal functions in ASIL-D that we have multiple point fault control or something like that. Just in the air traffic regulations, you have to overcome 5 barriers before at the end you have a critical probability for an accident. And I think that is the dimension where we have to think in automated driving. Of course, that based also on procedures and education of air traffic guides and pilots and stuff like that. But in any case, that is the dimension where we have to think. But random hardware failure, if there still became an impact at the end to our safety functions, we're using the wrong architecture and the wrong design.
I understand. Thank you.
You're welcome.
Bogdan, do you have any second question?
Do you really think that the highly autonomous or fully autonomous driving will still this SIL approach or SIL concept of functional safety will be kept, or will have as much power or as it is nowadays, mainly for highly embedded systems? Or would you think that some other concepts, maybe parallel to that, but some concepts, minimum endogenous mortality, for instance, in which the OEMs will have to make a proof when they validate their autonomous driving that they obey or they tested their systems for a rate of an accidents lower than the existing ones, and therefore their systems cannot introduce more accidents onto the streets.
So Bogdan, if I understood your question right, your question is in the autonomous scenario, if the SIL concept that we use today, will it still be used, or will we use some other advanced mechanism? Is that true?
Yes.
I think in general we have to use other technology at the end to control our scenario. We have to see in other industry how they deal with environmental impact. So at the moment we have no real idea how people who run into our vehicle or who run at the end in our trajectory, how to deal with that one and how to manage that one, what are the regulations for that one. There are quite a lot of other industries, they already did that experience and know how to deal with that. So from the robotics we know quite a lot of very good ideas how to do that and how to manage that, how to get the necessary precision, how to get the necessary safety into our system. We know it from air traffic regulations, we know it from railway systems, how to protect it, and just using a mechanical barrier or things like that is the question. But we must learn to make all that safety mechanism available for our technology. And that, of course, is a key technology. Do we get the environment protected? Do we get our mobility protected? Did we get the people protected which are close to our automated driving people, and also, of course, get really occupancy on the vehicle at the end protected sufficiently that people would see a benefit on that one and not just see a risk on that new technology.
No, because after all, functional safety is about risk reduction, accepted level or tolerable level, and still has an approach with that. It says that, systematic measures for system development have to be put in, so that the higher the seal, the more the measures, and also that the hardware components, they have reliability, they have cope with some failure rates. But some other concepts, they are a bit broader. They're not still addressing specific hazards or specific scenarios. They are rather about the overall system and about the social acceptance of the system.
Which one are you specifically talking about, Bogdan?
Well, for instance, I don't know too much about this concept of minimum endogenous mortality. But this is done. So if you want to deploy a system like, self-driving cars in a certain region or in a certain geographical area, first you have to count with, social acceptance of that system there. So that there should be some statistical criteria for that. Probably, mortality rate due to traffic accidents. And if you're making the proof that your system is not exceeding that threshold, this could be accepted.
It's more of an ethical issue of autonomous vehicle versus human driving a car.
Yeah.
So Leo.
We already discussed that we have a history of more than 100 years of road traffic safety. And we have regulations which continuously improve whenever we had issues with new technology, with the increasing mobility and easing number of vehicles on the road and stuff like that. And I personally doubt massively that you get the margin, how many people you are allowed to kill with new technology before you go at the end to any solution which would be acceptable. At the moment, we still have a rule as a safety engineer, since there is a credible scenario that you could kill people, you have to take measures on that you avoid it. And that is still the basic rule for all of that one, so that you get really the release, that you can bring higher risk to people walking around. I hope nobody really consider that. If we take higher risks at the end to bring new technology on the road is simply another question. But then we have to monitor that technology and have to see what is the new risk, what is the impact on the new risk, and also with the new risk, how we can protect people at the end to be violated from this new technology. That is the job from us, and not the risk to count people which are allowed to be injured or somehow bring harm to the people.
Previously, you were mentioning that you were not aware of any technology that made things less safer than the previous technologies. So certainly the social acceptance will be based on the credibility of the technology.
Yes, I guess so. But I think that here also statistics may play a role. That's why probably that there should be, or there are already discussions about the OEMs deploying self-driving cars, that they have to register the number of kilometers done and the number of disengagements at some central authority or things like that.
Absolutely. I think we are moving a little bit toward a legislation. Okay, Bogdan, it was really, really a pleasure to have you. Thank you so much. Really appreciate it.
Thank you very much, Bogdan.
Thank you.
Bye.
Bye. So in the end, Leo, I always ask a question that whatever we discussed today, we have disruptive technologies coming up, we have security risks, safety risks, but we are going in a direction where things will get better. Like with your last question, things was reflected. What are the most positive things do you think we'll see in the coming 5-10 years due to these disruptions, due to this technological advancement?
I think the most interesting was the development when I saw the last 25 years when you were a safety engineer. I think in the first time you're working with complete new technology, then you introduce in the automotive market, and it was at the end challenging to bring safety. But then about 5-6 years ago, We said, okay, make a process and make a standard procedure how to make it safe, and then you are fine. And then it became a little bit boring because we had the same technology and we just make processes and we consider at the end when you do that. So it was like a cooking recipe that you do, and the question was, is that really a challenge for the engineer? Is that a motivation for the people doing that? But now we're coming up that we make new function. We enable the industry to bring an automated driving car on the vehicle when we deal with safety. We can make the high voltage controllable for the consumer, for the people, for the society. So we are the enabler in safety to bring the environment, the new technology, the new change, and also the new business model for all the other companies which try to bring at the end data to the vehicle, which want to control the vehicle out of the cloud, or which try to bring environmental information to the vehicle, or just bring the information to the occupancy, which at the end doing maybe an interview or doing just their business work. Yeah? We are the enabler of that technology. You wouldn't have 150 years ago no railway without any safety. People didn't accept railway if you could not prove that you at the end can make the transportation of people safe.
Fascinating, I love that. So safety and security will be the enabler of these disruptive technologies. Leo, thank you so much for joining. It was really nice to have you here. I was really excited to have this discussion with you.
Thank you very much, Hassan. It was also a very interesting experience for us, and thank you for your invitation.
Thank you. So thank you very much for watching. We really appreciate your participation. Please feel free to write comments in this video if you have liked particular topics that we discussed. We'd love to hear from you. Thank you. See you in the next episode.
In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast@matrickz.de. We'll schedule a call with you during the recording and you'll be part of our show. Make sure you subscribe so that you don't miss any new episodes. Please share this video to help others get enlightened as well, and that would mean a great deal to us.